Hello, my name is Mr. Asprey and I'm back. Yeah! Thank you so much for all the support I received over the last couple of weeks. Absolutely amazing. And I'm going to make up for lost time. The first thing I'm going to do is I'm going to make sure I post every single weekday at 5 PM some IGCSE content, and also on the weekend I'm going to post like a larger video as well to help you smash your IGCSEs, which are coming up very, very shortly. And also I'm going to be trying my hand at live streaming, which I'm really looking forward to. And what I'm going to do is I'm going to do a masterclass on Zoom for grade 7 students, and also another one on Zoom for grade 9 students. So that will be this weekend, Saturday and Sunday. You can buy your tickets here. I think they are very reasonably priced, if I don't say so myself. And I'm going to be going over everything grade 7 on Saturday, so top tips, exam questions, the topics you want to focus on, and just how you want to prepare yourself for grade 7. And then again on Sunday I'm going to be doing something exactly the same but for grade 9 students, and again that's going to be those questions at the end of the paper, the real tricky topics, and I'm going to give you all my advice and all my guidance I can to help you absolutely crush your exam come Thursday. And also hopefully I'm going to do a live stream on YouTube on Tuesday as well, so if you miss these two then you can just log in on Tuesday, hopefully for a live stream, if I can get around to doing that, which I really hope I can. Okay, right, that's enough chat, let's get into the tricky question. Let's do it. Right, let's do it. So the first thing I'd want to do is I'd want to find as much information as possible. So I can label my diagram. I can see this is going to be 5 centimeters because it's a radius just like this one up here. And I can see this one's going to be 4 centimeters, just exactly the same reason. What I think would be really helpful is if I found this distance right down there, and also if I could find this angle in here, let's call it alpha, then that would also be really helpful. Okay, so let's start off with AB, this well, it's a chord essentially of the circle. Now how am I going to find that? I'm going to use the cosine rule on the left triangle. Now the cosine rule states that a squared is equal to b squared plus c squared minus 2 times b times c times cosine of capital A. Now capital A is the only angle in that formula, and the only angle we have is this one here, which is 50, which means that that angle points to the chord we're trying to find. So the chord we're trying to find is little a. So I can write AB squared, because that is the name of the chord, goes from capital A to capital B, is equal to, well, little b and little c, those are the two other sides of the triangle, which are both 5. So 5 squared plus 5 squared minus 2 times 5 times 5, and then times by cosine of capital A, which is 50 degrees. Okay, great. So that's going to give us a value, and then I can square root that to find whatever well, AB is. And that gives me a value of 4.226 when I put it into my calculator. Okay, fantastic. So that's good. And what I want to find now is alpha, the angle on the other side, the other triangle. So in order to do this, I need to use the cosine rule again, but I need to reverse it so that I can find an angle. So I need to rewrite the cosine rule. Now, I never remember what the cosine rule is for the angle, and you're not giving it in the formula booklet either. So what you can do is just rearrange this equation up here. So this big slab, which is minus 2bc cosine A, I can add that to the other side of the equation. So that becomes 2bc cosine of capital A plus A squared is equal to b squared plus c squared. I can then subtract the a squared, like that, and then I can divide through by 2bc. And that gives me my formula for cosine capital A. Okay, well, what is capital A? It's the angle, and the angle we're trying to find is alpha. B and C are the two sides kind of opposite, not opposite the angle, adjacent to the angle, which are both 4 in this case, so it's 4 squared plus 4 squared. A is the side opposite the angle we're looking for, which is the chord, which is the one we've already worked out, which was 4.226, and that's all divided by 2 times 4 times 4. Okay, so we can get a value for that. It will be a decimal value, and then we'll take the inverse of cosine to find alpha, and we get an angle of 63.77 when we put that into our calculators. Okay, brilliant. That's really helpful. Right, now we need to start actually finding the area of this thing. So what I'm going to do is I'm going to start by finding the area of this this sector here. So that's the segment, but the whole sector looks like this. Okay, so that's what I'm going to find first. Okay, so the blue sector there, well, to find the area of a sector, it's the same as the area for a circle, but what we need to do is take a fraction of it, and that fraction is the angle of the sector over 360. So times by pi times by r squared. Okay, great. So that's the whole sector, but I don't actually want the whole sector. What I really want is just the segment at the end. So the bit between the chord and that rest of the circle. So what we could do is subtract the triangle. So if I take away that triangle, it looks like that, and that's exactly what I want. Okay, so how do I find the triangle? Well, the area for the triangle is a half AB sine C. Again, that's in your formula booklet. Now, what does that mean? Well, if you've got an angle, a triangle, sorry, and you know the angle, call it capital C, A and B are the sides adjacent to the angle, we can always find the area. So it's a half of A, which is 5, and B, which is 5, times sine of capital C, which is 50. Okay, great. So that gives me my blue area, which is, when I put it to my calculator, 1.33. Fantastic. So what am I going to do next? Well, I'm just going to do exactly the same thing on the other side. I want this little segment in here, but what I'll need to do is find the whole sector. And again, the sector is the angle, which is alpha, which is 63.77, over 360, multiplied by pi times by radius squared. And then that gives me the whole sector. But I want to get rid of the triangle because then I'll be left with just that segment, which is exactly what I'm looking for. So I need to subtract the triangle, which is, again, using the area formula for a triangle, it's a half AB, which are the two sides adjacent, which are 4 and 4, times by sine of alpha, which was 63.77. And that gives me an angle when I put that into an area when I put that into my calculator of 1.73. Okay, right, we are looking good to finish this question up now, because what I'm going to need to do to find the area of R is just add together these two areas which I found out already. And that gives me a total of 3.06